Hello viewers, in today's class we are going to integrate an important rational function which is of the form uh, 1 over x times x raised to n plus 1. Clear? So here the form px over qx, this is a rational function and the form is 1 over x times x raised to n plus 1. So here px is a constant polynomial and qx is uh, the polynomial x times x raised to n plus 1. Okay. Now let us see the procedure or the method to integrate such type of rational functions. If we change the value of n, we can have integrals of this type, say x square plus 1. Here n is 2. If we take n is equal to 3, then we have x times x cube plus 1. If we take n is equal to 4, we have 1 over x raised to 4 plus 1, and so on. Clear? So viewers, in today's class we are going to integrate this function. So let us call this integral as I, and now we'll multiply the numerator and denominator by x raised to n minus 1. Clear? Now we have I is equal to x raised to n minus 1 and x raised to n plus 1 and times x raised to n minus 1. Here we have dx. So we have multiplied the numerator and denominator by x raised to n minus 1. Now here we have x raised to n minus 1 dx, and if we solve x raised to 1 and x raised to n minus 1, we have x raised to n and x raised to n plus 1. Clear? Now here what we will do, we'll multiply the numerator and the denominator by n also. Clear? Now this term becomes nx n minus 1 dx. So let us put, say, t is equal to x raised to n. So what will happen? dt over dx becomes nx n minus 1. So dt is equal to nx n minus 1 dx. Now we'll substitute nx n minus 1 dx for here dt. So here it becomes 1 over n, then we have dt here divided by x raised to n is t times t plus 1. Clear? Viewers, now we'll express this function in terms of partial fractions. Now we have 1 over t times t plus 1. So if we write this rational function in terms of partial fractions, so we have to write a over t plus b over t plus 1, because both these are linear factors. Now this can be written as a times of t plus 1 plus bt and divided by t plus 1. Clear? Now this equation gives us 1 is equal to a times of t plus 1 plus bt. This can be written as a plus b times t plus a. Clear? Now if we compare both the sides, we have a is equal to 1 and a plus b is equal to 0. This gives us a is equal to minus b. So therefore b is equal to minus 1. And this rational function becomes a is 1. So we have 1 over t and minus 1 over t plus 1. Clear? Okay. So now let us come to this integral. So here we have 1 over n, this is integral, and here we have 1 over t minus 1 over t plus 1 dt. Clear? Now this can be written as 1 over n. The integral of 1 over t is log of t, and here we have the integral of 1 over t plus 1 is log of t plus 1 and plus c. C is the constant of integration. Now using the property of log, which is log m minus log n, can be written as log of m divided by n. We can write 1 over n log t divided by t plus 1 plus c. Clear? Now we substitute the value of t, and t is x raised to n. So we have 1 over n log x raised to n plus 1 plus c. Clear? So this is the final integral of this function. Clear? So viewers, here the integral of this function, and this is 1 over x raised to n plus 1 dx, is given by 1 over n log x raised to n divided by x raised to n plus 1 plus c. Now if we have, say, n is equal to 1, then this expression becomes 1 over x raised to 1 plus 1 dx is equal to 1 over 1 log x raised to 1 plus 1 plus c. Okay? Similarly, we can find the other integrals by substituting or by varying the value of n. Suppose n is 2, then the integral of 1 over x square plus 1 dx is equal to 1 over 2, because here n is 2, log we have x square over x square plus 1 plus c. Okay, so we always remember how to integrate a function like this, and it is better if we directly or if we remember the integral of this function as a formula. Clear? So the integral of 1 over x times x raised to n plus 1 is 1 over n log x raised to n divided by x raised to n plus 1 plus c. Clear?